Welcome to Science Innovative Brain. Today's video lecture we will discuss what is an inductance factor for the ferrite core transformer and how we can calculate it with the help of LCR meter. So first we will discuss what is inductance factor AL factor for the ferrite core transformer or any high frequency transformer. So inductance factor is defined as a self-inductance per unit square of the number of turns of the coil wound on a magnetic core of a given shape and dimension, and is determined by the following formula, and its unit is nanohenry per turn square. Let us assume a step-up transformer having turns in secondary coil is 10.5 and its inductance is 330.75 microhenry. Then if you put the values in the formula, then you can find the AL factor is 3000. So in this manner you can also calculate the value. Now we will discuss how to find the AL value of unknown core. If you are having a ferrite core whose data sheet is not available and any marking is not there, so how you can find using LCR meter. So you have to follow the 6 steps, then you can find out the value. So first step is wound the enameled copper wire on the core. Then second is count the exact number of turns. Third, fix the core properly without any air gap between the core. Measure the inductance value using LCR meter accurately. Put the value in the formula and get the AL value. You can find the value by putting the inside the formula. Repeat the process and take the average for the better result with different number of turns. Now we will discuss how we can find the AL value of known core. So first of all, you find the data sheet of that core on internet, and then you can check it in data sheet and you can find the AL value for the core. I have shown here in red mark, you can find it there, AL value is written. Now the time is for experiment. We will do the experiment and will show how we can measure the things in using LCR meter. I have this ferrite core and we have to find the inductance factor for this ferrite core. We will take some copper wire and we will make some 20 turns so that we can measure the inductance. I have made some 20 turns from the copper wire. If you count it exactly, it will from here to here is a 20 turns. Now this coil I will insert in the ferrite core. So this is the ferrite core and I will insert so that we can make a inductance and we can find the inductance factor. Now we will connect this circuit like this and this coil is ready. Now we will fix this part so that there should no air gap. So with the help of tape we will properly tighten this part. Now the core is fully tightened with the help of tape. Now we will use LCR meter. So here I have LCR meter, and first we will calibrate this LCR meter so that we can get the accurate result. For the calibration, we will short this two terminal and we do the calibration. I have shortened the terminal and now I will press the calibration. So it is calculating and saving the data. After calibration, we will connect this to the coil. I have connected the LCR meter to the coil and it's showing some result. I will press the core little bit so that it will tight properly. So whenever I am pressing, this result is changing and it's showing 793. We will take average value. So we find the value 793 and now we will calculate and check what is the inductance factor is coming. Now we measured L is equal to 793 microhenry. We will convert this into nano henry. 793 multiplied by 1000, so it becomes as a nano henry. And we have number of turns is equal to 20. Now AL factor formula is AL is equal to inductance divided by number of turns square. So we'll put the value. So 793 multiplied by 1000 divided by 20 square. We will get the result. AL is equal to 1982.5. So this is the inductance factor for this transformer. It may be plus minus 25% tolerance because instrument and measurement error can possible.